Hi, good morning. So, in the last class, we have discussed about how to calculate empirical as well as the molecular formulas. So, in that regard, we have discussed about one problem. So, I hope you all understood that problem. If not, please do ask, right? So, this is a bit trickier. If you know the columns and how to put the values, then definitely when you can come to know how to calculate the empirical as well as the molecular formula. So today we will see one more problem of type, calculation of empirical as well as the molecular formulas. So consider one more problem. So the problem is like number 2. So if you want, you can take it down so that I am not having so much space in my board. So later I will directly write, all right, the values. A compound containing a compound containing 4.07% of hydrogen, comma 24.27% what carbon, 71.65% chlorine. Calculate empirical and molecular formula. Empirical and molecular formula given we need to calculate both empirical as well as the molecular formula given molecular weight of a compound. Molecular, directly they have given molecular weight of a compound is 98.96 gram. So this is our given. So you copy these values. So I will directly write here, that means the table, and then directly we will calculate. Why? Because I am not having so much space, right? So a compound containing, you once again you can go through this question. A compound containing, there is an organic compound again, and in that organic compound the hydrogen percentage is 4%. I mean 4.07%. And in that particular compound carbon is of 24.27%, and now chlorine is present like 71.65%. Here in the last class we have calculated the problem, like only in that problem they have asked you only about the empirical formula, but now we need to calculate both molecular formula as well as the empirical formula. In the last class, I have given molecular formula is equal to n into empirical formula, or else n is equal to what? Molecular formula weight divided by empirical formula weight, right? So that we require over here in this problem. So that's why I said to you, you keep that formula with you, right? So now I just copy these values. Later directly I will put the values, right? So now see, again, before solving this problem, in the solution we have to write about what are columns, I mean different columns. So type of atom, again the same type of atom. Next, percent of atom, molecular mass of atom, ratio. Next is ratio. Ratio is nothing but what? Percent of atom divided by molecular mass. In short, I will write. Already you have formula, right? Then small ratio. Small ratio is nothing but, sorry, simple ratio. So simple ratio. Simple ratio is nothing but what? Simple ratio is equal to ratio. Whatever the ratio value we will get over here in this column, we need to divide it with the small ratio. Then we will get the simple ratio. and finally whole number. Right. So this is these are this is the column. I mean chart. We need to have this chart, and then later everything has given in our problem. We just go through that problem. Definitely you come to know what all they have given in different forms. So now consider that problem. Read it out once again. So a compound containing, first they have given about the hydrogen. So let us put hydrogen first. Type of atom first is hydrogen, and what is the percent of hydrogen? 4.07%. You go through that problem once, right? So 4.07%. What is the molecular mass of hydrogen? 1. Directly 1 we can put it over here. And then ratio is nothing but what we need to do, we need to divide it with this, right? Percentage is 4.07% divided by 1. So how much we will get? Nearly, I mean definitely 4.07 only the ratio over here. So don't go for simple ratio, later we will do. So now this is one element, this is about one element. So now one more. Next is they have given, continuously read that there is a carbon, right? Carbon, and whose percentage is 24.27%, and carbon molecular mass is, we already know, 12, right? And now calculating ratio is nothing but what? Percentage is how much? 24.27 divided by 2, which is nothing but 12 point something, divided by 12, sorry, not 2, 12. So nearly it will come 2.27, right? 2.27. Okay, let us go for one more, that is one more, there is a chlorine, correct? One more is there, one more element is there in this particular example, that is what? Chlorine. So now coming to the chlorine means Cl, right? And what is its percentage? Chlorine percentage is, right, 71.65, and whose atomic mass, I mean molecular mass, is 35.5. If we calculate the ratio, that means 71.65 divided by 35.5 means nearly we will get 2.01, right? 2.01. This is the case. So now go for simple ratio. So what will be the simple ratio over here? So here if I see the hydrogen ratio, that is 4.07, and now what is the what about carbon ratio? 2.27. So this is lesser than the hydrogen. And now coming to the chlorine, 2.01, that means 2.27 is more than what? 2.01. So thus here this becomes a small ratio, 2.01. Like how when we can calculate this small ratio. So now coming to the after knowing the small ratio, when we can calculate the later part, simple ratio is nothing but what? 4.07 divided by what is our simple ratio, small ratio? 2.01. Nearly how much we will get? 2.07. Here I can write 2.07. So that means the whole number is 07, means nearly it is 2, right? So now coming to this, I mean carbon. So already we know what is the small ratio, right? So see here, ratio of carbon is 2.27 divided by what is our small ratio? 2.01. That means nearly it will also come as a 1.27. 1.27 and 2 mean 2, 3, 4. 1.234 like this one we can take as 1 itself. If it exceeds 5, then definitely one we can move for whole number, that is 2. But it is lesser than 5, so thus 1.2 only. So thus when we can say 1 only. So now coming to last one, that is chlorine. Chlorine ratio is what? 2.01 divided by 2.01. This is very simple. So it is 1 only. So whole number is also 1. So now after having these things, one we can say, right? So write down, start with the carbon, right? It will be correct manner, or else empirical formula empirical formula EF empirical formula is equal to, see, we have carbon and then hydrogen and then chlorine. So now see the whole number. Whole number is for carbon how much? Only 1. For hydrogen 2, just put 2. Chlorine is also 1. So thus this is our empirical formula. But they have asked about the molecular formula also. So molecular, for calculating the molecular formula, what we require? N value. N value is nothing but what? See, for calculating, I will write the formulas and later I will go for the explanation. See here, molecular formula calculation we require what? N into empirical formula, right? For molecular formula, you remember in the last class I have explained about this, right? For calculating the molecular formula we require N value. So for that N value, N is nothing but what? N is equal to molecular formula weight divided by empirical formula weight. So that means molecular formula weight they have already given in the bracket, right, in the question itself. But what we need to calculate? Empirical formula weight. We need to calculate the weight of this, right? So simply I will calculate over here. How to calculate? So first you write it down the compound. So CH2Cl, right? Correct? So now 1 into C, there are only 1 C in this compound, so therefore 1 into C plus, add up 2 into H, HR2, that's why 2 into H plus. What about Cl? Cl is also 1, so therefore 1 into Cl. So 1 into 12 plus 2 into 1 plus 1 into 35.5. So how much? 12 plus 2 plus 35.5. It will come nearly 49.5. So the gram. So this is the, you remember this, right? And you copy this, right? So why? Because I am not having space. That's why I will rub this, right? 49. So see here, 49.5 gram, right? So this is our molecular, empirical formula weight. So now directly when we can go, see, if you copy it down, then I will rub it, right? So now see, 49.5, remember this, and you copy down, and then later go for this N value, finding out the N value. N is nothing but molecular formula weight. Molecular formula weight, how much they have given? Molecular weight 98 point how much? 96 divided by how much we got? 49.5. So nearly this value is nothing but 2. So or else N is equal to 2 1 we can say. So this is our N value. So now you go for molecular formula directly. So that's all. So molecular formula is equal to, right, N. What is the value of N? 2. What is our empirical formula? This, right? What we got? This. So that means CH2Cl. So now calculate. 2 into C, C2. 2 2s are 4. 2 into H into 2, that means H4. And 2 into Cl, Cl2. So this is our what? Empirical as well as molecular formula. I revise you that once if you got the empirical formula, what we need to do is you just calculate the weight of this as I did, and then later you go for these two formulas. First go for N is equal to molecular formula weight divided by empirical formula. Always molecular formula weight they will give, definitely, no doubt. And for empirical formula weight, we need to calculate the empirical formula. Once if you get the N value, definitely very easily when we can calculate the molecular formula, right? So this is all about today's class. See here, if you have any such type of different examples, please calculate, please solve as well as empirical as well as molecular formula, and please send it to me, right? Thank you.